Okay, so this is day 6 of angles. All right, so we are reviewing terms and then solving some problems. Okay, so an equilateral angle, these are all terms that you've heard before, is a triangle in which all 3 sides are equal. All 3 internal angles are also congruent to each other and are 60 degrees. Okay, make sure you've written those down. Okay. All right, next up is an isosceles triangle. An isosceles triangle is a triangle in which 2 sides are equal in length. The angle opposite the 2 sides are also equal. So you'll know you have an isosceles triangle if you have a triangle that has tick marks that match each other like this. Or they can be a double tick mark or even a triple, depending on what kind of figure you're looking at. But it's important to know that these angles that are opposite the sides that are equal are also equal. Because we're going to use that property. Ray.
So do the tick marks show that the sides are the same?
Yep. So when you have the same tick mark, it shows that those sides are congruent. So the tick marks have to match. Okay. So a right triangle is a triangle in which one angle equals 90 degrees. No surprises there, right? And a scalene triangle is a triangle in which none of the sides are equal. Okay, so folks, what do the angles in a triangle add up to? Kendall? 180 degrees. Good. That's your next slide. Charlie? It doesn't have to be because you could have 2 sides that are equal in a right triangle. It could potentially be, but we would usually refer to it as a right triangle just because it's got that right angle in it. All right, so let's use these properties to solve some problems. Okay, and this first one we're going to find for x. What kind of triangle are we looking at in number 1 here? Abby? Yeah, that's a scalene triangle. Now that doesn't really help us solve it, but it's fun to know. All right, how are we going to solve this? Liam?
I would add up 85 25.
Okay. And then what?
110. 180
and 180 minus 110 is 70 degrees. Is it 110?
Yeah.
Okay, great. Good job. And then we subtract. Why did you subtract from 180, Liam? Yes, exactly. So angle X equals 70 degrees. And you know what? Let's all practice making sure our angles notation is correct, okay? So I want that little angle sign, and I want the degree sign in your notes, you guys. Make sure you have that. Okay. Let's take a look at the next figure on number 2. PSQ and QRS are 2 isosceles triangles. So you can tell that these 2 sides are equal to each other and these 2 sides are equal to each other. Find angle QRS, so this one, and angle PSQ, this one. Okay, any ideas? What do you think? Yeah, Anthony, how would you go about solving those? You don't know that. Are you saying this angle? I'm sorry, let me erase my lines here. Are you saying this angle right here is 70 degrees? Oh, you're talking about RQS. Now wait a second. I think I marked the wrong angles for us to find, didn't I? Yeah, I did. Because we want to find QRS. We want to find this guy right here. And then, okay, so you're telling me you marked that one 70 degrees. Okay, great job. All right. Okay. Okay, good job. Okay, so you did 180 minus 140 equals 40 degrees. So angle QRS equals 40 degrees. Well done, Anthony. Nice job. How about you have that? Well, I'm going to let somebody else go. All right. Maddie, help me out.
So if since it's a scaling, that means angle PS is going to equal.
No, it's not a scaling. It's an isosceles triangle. That's okay.
Sorry.
No, that's okay. Do you want to keep going though?
Yes.
Okay.
PQS is so
Yep.
if you do that, 80 minus that 150.
Mhm. Very well done. Okay, so 180 minus 30 equals 150. Now that's going to equal the total of these two angles that are equal to each other. And so we want to just divide by 2 to give us the measure of each of those angles. So what is that, Maddie? 150 divided by 2. Nice job. Okay, so angle PSQ equals 75 degrees. Awesome. Usually I have to teach that, but you guys figured it out. Way to go. Okay, let's keep going. Number 3, ABC is an equilateral triangle, and you can tell also because it has tick marks right here. So what does that mean? Let's just stop there. What does that mean for all of the angles in that equilateral triangle? Annie? Yep, and they're all going to be 60 degrees. Way to go. So let's go ahead and just mark that on our diagram there. And then ACE is an isosceles triangle. Okay, so it looks like this side is equal to this side right here. Find angle BAC. Let me just change colors here. Oop, not purple. The triangle's purple. Okay, find angle BAC. We want this one. Oh, that's a no math one right there, isn't it? And find angle CAE. So this one. Okay, well, let's do the no math one first. What's letter A? Alda? Yeah, we already figured that out because we read the problem and we know that an isosceles triangle has equilateral triangle has angles that are 60. How about angle CAE? What is that one going to be? Alex?
70 degrees.
Okay, how did you find that?
So first I subtracted 180 from 40.
You subtracted 40 from 180.
Yeah.
Okay.
And then I got 140.
Yep.
And I divided by 2.
You got 140 and you divided that by 2. And you got 70 degrees, so angle CAE. Now remember, guys, we're all practicing our angles notation equals 70 degrees. Yes.
Why? Because the tick mark shows 34, right? So that's 6.
Well, the sides are equal. So we're talking about this isosceles triangle right now, right?
Yeah.
Okay. So the sides are equal, right? So that means that the angles opposite the equal sides are equal to each other. Does that make sense? They're not necessarily equal to the equilateral triangle. It's just that the side is the same length. All right, let's do some more. How are we doing, you guys? Okay, Kala, you had your hand up. Yeah. Why did we divide by 2? That's a great question. Okay. So the reason we're dividing by 2, first of all, let's start at the beginning. How many degrees do all of the angles in a triangle add up to? 180. So when I'm looking at this angle, I wanted to find this CAE right here, okay? This triangle is an isosceles triangle, and we know that because it's got 2 matching tick marks on its side. And it tells us, so right here and right here, right? We have the vertex angle, which is 40 degrees. Since all 3 angles need to add up to 180 degrees, and the 2 angles that are opposite the equal sides, the sides that are equal, those angles are also equal. So if we took 40 degrees away from 180, we'd get 140. The 140 is the measure of those 2 angles added together. So we just need to divide by 2 because they're equal. Well, that's one of the properties of an isosceles triangle, is that those angles that are opposite the equal side, think of it like the angles below the equal side. I don't know if that helps, but those are equal. Okay. Any other questions on that one, or anybody else want me to slow down a little bit? We're doing okay? Bastion? Well, let's let's read it first and then I'll have you help me. Yeah. So it says ABC. Did I skip one? That's it. Okay. Okay. So find angle A and angle B. Looks like we've got a right triangle here. What does that mean for this angle right here? What kind of degree measure is that angle? Tyler? It's also 90 degrees. Good job. We've got a degree measure here. Oh, what's this degree up here?
90.
That's also 90. Okay. All right. It says find angle A and angle B. How are we going to do that, you guys? Okay, Ashton.
So, so 35 is in the
Okay.
box, the right angle on the bottom right.
Right here? Okay.
So I added B plus
You subtracted 125 from 180. Okay. Okay. It just, hang on just a second. My computer's halting. Okay, so angle A equals 55 degrees. Okay, nice job. Now what? Yep, we've got two complement. Okay, great job. So you subtracted 55 degrees and you got angle B equals 35 degrees. Great job. Okay, well done. Does that make sense to everybody?
Yeah.
Great. So remember when I told you guys that this unit is about figuring out like the angles that you can see and know and then just kind of progressing through the problem? So far you haven't really had to do that, but today's the day when you start doing that. So on the homework, and we're going to do some more problems here, but on the homework tonight, that's kind of what your strategy should be. Start marking down the things that you know and the things that you can figure out until you get to the angle that you need to solve for. All right, so we've got DAB is a right triangle. Angle ABC is an equilateral triangle. We want to find angle X. Okay, well, when I look at this, if I've got an equilateral triangle, these are some freebies right here, aren't they? Oh gosh, this is an easy one, isn't it? What do you notice right here? What is that, Tyler? That is a right angle right there. We've got complementary angles. So what is angle X going to equal? It's going to be 30 degrees because it's 90 minus 60, right? Good job. I kind of feel like maybe you guys are ready for some Toyos and that we don't have to do all of these as notes. Let's do some of these do get a little bit more complicated. So let's do one more together and then you guys will do the rest as Toyos. So just this next one with the rectangle. All right, pure is a rectangle. It doesn't look like it, but it is. Find angle Y. Now let's just hold the phone here for a second. If it's a rectangle, what are all of these corners going to equal?
Right angles.
Yeah, 90, 90, 90, 90. Elin. Yeah, please. Yep. Okay. Nice job.
And then I did 180 minus 50 plus 90.
You did 180 minus 50 plus 90. Okay.
And I thought angle Y was
Okay, nice job. So angle Y, oh, see, angle Y equals 40 degrees. Okay, way to go. All right, why don't you guys go ahead and work on the rest of the problems and we'll check back in with each other in about 8 minutes or so. All right, so we have CALM is a square. What does that mean for all of the angles? Yeah, they're gonna all be 90, right? Okay, so we can go ahead and mark those. Find angle W. All right, does anybody have an idea of how to find angle W? Okay, Kala, what do you think angle W is? It's not 25 degrees. Ainsley? No. Anthony? It's 20 degrees. Okay, so how did you find it?
So I'm pretty sure CL is fine.
see, yeah, it is a straight line.
Okay,
Yeah,
so-
it's, you can see it's an angle bisector,
Yeah.
but
So if you, so since MCA is 90 degrees, the line basically cuts it in half. Make C. Okay, so they're both 45.
how do you know that? How can you tell? Okay, so you're right. You're right. No, I keep going, Anthony, but you're not, what you're saying so far doesn't prove it. So in geometry, we have to prove stuff. But you're right. Stop. Thank you. I'm looking at him because he's helping me. Thank you. So you're 100% correct. It's just that we haven't proved it yet. So you're saying this is a straight line. Why does that divide each of those angles into 45? You do know it. You learned. It has something to do with the length of these and the fact that it's a square. Yeah. So the fact that it's a square means that all of those sides are equal, right? Okay. If all of those sides are equal and this side is equal to this side is equal to this side is equal to this side, that means all of those angles have to be equal as well. And since we're dividing 90 degrees and those have to be equal angles, then they would be divided in half and that would be 45. So sorry, I'm making you work for it. Keep going. Okay, so you know that this is 45 degrees. Okay? And this one's also 45 degrees? Okay.
So
But we have to find this one right here.
So I found the.
You found this guy right here?
No, not that one.
You found this one? Okay, so okay. Okay, so hang on. We got 70 degrees right here. And then you did 90 minus 70 and you got 20. And then just to finish it off, the measure of angle W equals 20 degrees. Very well done. Good job. Okay. And does everybody understand that? Bastion? Sure. Yes, you may. Okay. What did you get for the measure of angle X or S, excuse me?
I got.
You got what, 50? Great job. Okay. How did you get 50?
So since angle BRA is
B,
90 degrees,
yep. How do you know it's 90?
because that's above
Because it's 90 up here?
there.
Yeah, but we're not making a box, it's a trapezoid. What properties of a trapezoid lead you to believe that this angle down here is 90 degrees?
Okay, I'm going to, so we don't know when.
Okay, maybe somebody with a blue sheet out could explain this to me. Annie?
Yeah, I don't remember.
You don't? Okay, that's all right. What do you think?
Well, wait, what do you want me to say?
I want you to explain why we know this degree measure is 90 degrees. Because it doesn't tell us that. No, we don't get to use it looks like in geometry. What else? Alex?
I'm pretty sure because BRA is a right angle.
BRA is right angle. It is. It looks like one. But how do you know? Because this could be like this might not be a straight line. I mean, well, it is a straight line, you can tell. But how do you know that that's a right angle?
It's a straight line.
Okay, but that's not why. Elin. Yes, good job. Because BE and RA are parallel. So this is the definition of a trapezoid, you guys. A trapezoid means that we have two parallel lines joined by two lines that are not parallel, okay? When we have two parallel lines, if you were looking at your blue reference sheet, you would notice that we have a couple rules that would apply here. I want to see your both of your hands on top of your desk. Taking notes. Thank you. And that is like we could use all kinds of things, but they have to be equal to each other. Since this line is perpendicular to the first parallel line, it has to be perpendicular to that second parallel line. We could use z-rule. We could use alternate angles, alternate interior and exterior angles. Here's the z-rule. That would be that this angle is equal to that angle on the outside, but then since they're 90 degrees, you would know that it has to be equal to that angle as well. Okay. All right, what else? Sebastian, you are starting to help me out there. Now that we know for sure that that's 90 degrees, where can we go from there? Okay. And you use complementary angles to get good job. Okay, so the measure of angle S equals 50 degrees. All right, nice job. Okay, I said I'd give you guys a couple more minutes to try to figure the rest of these out. So why don't you go ahead and do that now? Good. 3 more. So for that exit ticket, by the way, you guys, it says AC is a line of symmetry. What that means is that it means that everything on both sides of that line are equal. That makes sense? Symmetry means equal. So we just talked about what that means. It means that two sides are parallel. DBC is an isosceles triangle. Did I assume that? I did. Okay. And it shows us that those two sides are equal. BD equals CD. Find angle ABD. So we want that angle right there. All right. Who thinks they've got it? They've got it. Ainsley. What did you say? Yes, it is. How'd you get there? Nice job. Okay. All right, Elin? Yep.
So if you have 80, it's to 189.
Okay.
And you divide it by 2 to find angle B. And
Yep. Good job.
and then is 90 degrees. So you do 90 minus 60 degrees.
Start taking notes, please. Okay. Great job. So you said that you know that this is 90 degrees. Yeah, because we've got two parallel lines again, and this is a line that's perpendicular up here, so it has to be perpendicular down there. So 90 minus 50 will equal 40 degrees. And that means that angle ABD equals 40 degrees. Nice job. Okay, let's do the next one. AB is parallel to ED and EA is parallel to DC. Find angle AC. Charlie, help me out. Okay, nice job. So you'd use the Z rule. Way to go. So you saw this. We know that these lines are parallel. And you know what? You guys can see that too. These marks right here, that means that this line is parallel to this line, and then this line is parallel to that line. So good job with the Z rule. There it is right there. Since this is 60 degrees, alternate interior angles, that is 60 degrees. That's a no math problem. Way to go. All right, let's go ahead and go over the exit ticket. I won't collect it. Okay, find angle CAE. What do you think, Finn?
One is symmetry.
Okay. It's okay. Yep. Angle C down here is 25, right? Yep, so this would be 25. Is that what you're telling me? Okay.
That was 20. And then that would be 455.
So you're adding 110 plus 25, and then you're going to add this 20 to it. Okay. I see where you're going with that. 110 plus 20. Hang on, let me write it down. Plus 20 equals 155. Okay. Yep. Yeah, nice job. So yeah, way to go. So since these two angles, so he just still used angles in a triangle. All of them have to equal 180 degrees. And the measure of this is the third angle in the triangle that you were accounting for, but you took 20 degrees off of that triangle right up there. So good job. Angle CAE equals 25 degrees. Okay, well done. All right, so workbook exercise 5 is your homework for tonight.